Alright, I come back here with another segment. We are continuing with our June examination question paper. We are now on question number 6. The first question says determine f prime of x using first principle if f of x it is equals to 7 plus 5x. Alright, let's acknowledge what we have. F of x is equals to 7 plus 5x. This one is given. And then we need to come up with our x plus h. This is going to be 7 plus 5 into x plus h. This is going to give us 7 plus 5x plus 5h. Alright, so this is our x plus h. Now, the formula in the formula sheet, make sure that you copy it correctly. It says f of x plus h minus f of x and then all I'm copying it incorrectly. It's f prime of x equal to the lim as h approaches 0 into f of x plus h minus f of x, and then you divide everybody by h. So you're going to have the limit of h approaching 0. Substitute your x plus h is this one here, so you're gonna have 7 plus 5x plus 5h minus open bracket 7 plus 5x, all of this divided by h, multiply by removing the bracket. So the limit of h approaching 0, 7 plus 5x plus 5h minus 7 minus 5x, all of that divided by h. Now let's see. Now we've got positive 7 and negative 7, they give us 0. 5x and 5x, they give us 0. So you are left with 5h divided by h, and the answer here will give us 5. That is our first principle there. And then 6.2, what do we have on 6.2? 6.2, it says determine f prime of x if f of x, let's write it down here, if f of x it is 2 into the square root of x minus 3x to the exponent of negative 1 plus 4. So first thing first, let's make sure that everything is in exponential form. So this is going to be 2 multiplied by x to the exponent of half minus 3x to the exponent of minus 1 plus 4. Now we can find the derivative. F prime of x, it is equals to, remember the rule, you take an exponent, you multiply it with the base, and then you take 1 from the exponent. And then you do the same thing here, minus, you take negative 1 multiplied by 3, and then you're going to have x into minus 1 minus 1. The derivative of a constant is 0, so we'll just put it here and just say plus 0 there. And then when you simplify this, 2 and 2 they divide, we'll be left with x to the exponent of half minus 1 is going to give us negative half. And then these two, they're going to give us a positive 3x to the exponent of negative 2. If you want to write it in a positive exponent, but this is the final answer. But if you want to express this in positive exponents, it's going to be 1 divided by the square root of x plus 3 divided by x squared. So this is one form of writing the same thing as this one up here. All right. Moving on, 6.3, I will erase everything soon as I don't have space. So 6.3.1, you are given that y it is equal to t to the exponent of 2 minus 4 all divided by t minus 2. What is the question? Simplify y. Okay, Simplify y, you will realize that what you have in the numerator is a difference of two squares. So basically, just factorize your difference of two squares. You're going to have t minus 2 and also t plus 2, all divided by t minus 2. You have t minus 2 in the numerator and also in the denominator. So simply this one and this one, they cancel out, leaving us with y to be equals to t plus 2. That is our final answer there. And then 6.3.2, 6.3.2, they say then determine dy over dx. Be very careful here. Dy over dx of this one here, there's no x here, you are given t, so that means t, you're going to treat it like a constant, just like you're going to treat 2 like a constant, because here the notation says you're differentiating y with respect to x, but when you look at the equation, the expression, it does not have x. So it means that everything you have here is constant. So that means t is constant, 2 is constant, so the derivative of constant is what? 0. So that is the final answer there for 6.3.2. Let's see what we can do with question number 7. Thank you very much.